So yesterday and the day before we talked about proportions, right? Okay, somebody tell me. Is it green?
Nope, no. There's no.
Is it green?
No.
Is it green?
Yes.
Okay. All right, so somebody tell me about proportional relationships. What does it mean if two ratios are proportional? What does that mean? They have what? Lucas? They're equivalent, right? 1/4 is proportional to 2/8, right? Right? Okay. So now we're going to do, now that you understand proportions, okay, and we spent a couple days on how proportions work, we're going to start to apply that, okay? So this lesson talks about how to understand proportional relationships in a real way. Okay, you guys always ask, when am I ever going to use this? Okay, there are ways you're going to use this kind of math. Okay, maybe not like the proportions we saw yesterday with the ginormous numbers. Okay, but you'll see how we can use this all the time. Okay. All right, so if we look at this example, when we talk about the introduction to this lesson, when mixing blue paint and yellow paint to make green paint, the amount of blue and yellow can cause a lot of variations of green. Would you guys agree?
Yes.
I mean, if you use too much yellow, it's going to be what? Lighter. If you use too much blue, it's going to be darker. Okay, good. So there's very, very important ratios and proportions that we use. Now, how many of you have ever been with your parents when they go to Lowe's or Home Depot when they get paint made? Okay. Now, it's all done by computer, okay? But it puts a certain amount, it's what they call tint, into that paint so that when they mix it, they have that exact color, right? Is it important for that to be very accurate? Yeah. So like the proportion of blue and gray that goes into the white base paint, it's very, very specific. Does that make sense? Okay. Yes.
I just realized I left my sunglasses back at the gym.
Okay. Can I do the lesson and then have you run down there? Will that be okay? Do you need them for class? No? Okay.
I mean, I just don't, they're new and I don't want to.
I totally understand. Yeah. Okay, so let's continue. It says you could use 1 part blue and 1 part yellow, or 3 parts blue and 1 part yellow, including white paint in the mix, and to give it even greater variety. Okay. So let's say we did 4 parts blue and 4 parts yellow. Would that be the same shade as mixing 4 parts blue and 2 parts yellow? Would that be the same thing? Will we have 2 different colors? Okay, listen to what I said. If I put 4 parts blue, 4 parts yellow, and I mixed them together, and then I did 4 parts blue and 2 parts yellow, are those going to be the same? Those would not be proportional, would they? Okay? All right. Okay, this is your objective. Okay, I want you to write this down. Your objective for today's lesson. Yes, by all means, go ahead. All right, what I want you to do, write this down. Your objective is the second sentence here where it says, recognize and represent proportional relationships between quantities. Okay? See the highlighted part right there? By the time we're done with this lesson, you should be able to recognize and represent proportional relationships between quantities. Okay? Okay, remember back when we did the first lesson and we did those tables? And we were able to find answers using those tables. Do you remember that? Okay? If I had like 1/4 was equal to 1/8 of another one. Okay, those were an introduction to proportions. Okay, but we're still going to use tables. Okay? Does everybody have that written down?
No.
You want me to read it? Recognize and represent proportional relationships between quantities. Okay, are we good on that?
No. Yes.
Almost?
Almost, yeah.
All right, can I continue now? Okay,
Yes.
here we go. So some of the stuff you're going to learn about in this chapter, in this section I should say, okay, proportional relationship. We already know what a proportional relationship means, right? 2 equivalent ratios. So we're good on that. Okay, so let's look at this example. Okay, when baking, the ratio of ingredients is important to maintain. The table shows the common recipe for pizza dough. Too much or too little of any ingredient will not create a good dough. In this recipe, the ratio of cups of flour to cups of water is 3 to 1. Okay, and what does that mean? That means 3 cups of flour for every what?
1
1 cup of water. Good. Suppose you wanted to make 2 batches of dough. Is the ratio of flour to water the same? What if we wanted to make three batches? Well, if we wanted to make 2 batches, would we still use 3 cups of water, 3 cups of flour to 1 cup of water? If we wanted to make 2, what would we do with those 3 cups? We would double it, right? And then we would double the amount of water, right? So 6 cups of flour to 1 cup of water. Would that be a proportion? Think about what I said. 3 over 1 equals 6 over 2. Would that be a proportion?
Yes.
Yes, it would. Okay, good. All right. So this is a bar diagram that kind of shows us what we're talking about. 3 cups of flour for every cup of water. So if I did 3 batches, how many cups of flour would I have? 9. How many cups of water would I have? 3, right? Okay, that would be an example of a proportional relationship, wouldn't it? So knowing that, if you wanted to make 10 batches of pizza dough, could you figure out how much you would have to do? You could, right? Multiply each quantity times what? So just tell me, how many cups of flour would I need for 10 batches of pizza dough? 30. How many cups of water would I need? 10. Easy, right? Okay. All right, so let's look at this example. Okay, this says the recipe for a homemade glass cleaner indicates to use a ratio of 1 part vinegar to 4 parts water. Okay, what's important about that? Even though it just says parts. Okay, 1 part of vinegar for every what? 4 parts of water. Agreed? Okay, Elise used 3 tablespoons of vinegar and 12 tablespoons of water to make the cleaner. Okay, is this relationship between the vinegar and water in the recipe and the vinegar and water in Elise's cleaning solution a proportional relationship? What do you think? What do you think we should do? Let's first write the proportion of how much vinegar versus water. 1 over 4, right? And what did Elise do? What did she do? She did 3 parts what? 3 tablespoons over what? 12. So what we're asking is 1/4 equivalent to 3/12. It is, right? Okay, we can simplify 3/12 to what? Anybody? Chase? 1/4. Do they equal each other? What could we also do if we had 1/4 equals 3/12? Who remembers, what did we learn yesterday? Cross products. Good. 1 times 12 is? 3 times 4? Did it work? Yes. Okay.
I don't think I was here for that.
You weren't. You know, and I'm not sure why the lesson didn't show up on Plus Portals. Okay. So we see what we've got here. 1 over 4, okay? 3 over 3. So yes, those were proportional. Okay, you guys look at this one. You guys tell me in your notes, tell me if you think this is a proportional relationship. Okay, the recipe for a homemade glass cleaner indicates 1 part vinegar to 4 parts. Autumn uses 2.25 and 9 ounces of water. What do you think? What do you think? Let's write this out. This says 1 part vinegar to how many parts water? What does it say there, guys? 4. Okay? So 1, 2, 3, 4. So if she does 2.25 and she wants to use 9 ounces of water, basically what we're looking at is 1 over 4 equals 2.25 over what? 9. So how are we going to figure, we don't need a calculator for this, how are we going to figure out if these form a proportion? Cross products. Okay? So let's do this. First one's easy, right? What's 1 times 9? 9. 2.25 times 4. Well, let's do that. 2.25 times 4. What's 5 times 4?
20.
Okay, carry my 2. What's 2 times 4?
10.
Plus 2? 10. Okay, carry my 1. What's 4 times 2?
8.
Plus 1?
9.
How many decimal places am I talking?
2.
Okay, so this is 9. Do they equal each other?
Yes.
So was that a proportional relationship? Yes. Okay, does that make sense how we figured that out? Now that you know how to use cross products? Yes? Okay, next example. Okay, let's look at this one. Sorry, this is taking a while to load for some reason. Oh, contact support. I'm not going to contact support. I will just look at the example in the book. Let me try it one more time. Maybe. There we go. Okay. All right. Somebody read that for me, where it says a 5 mile. Somebody read that. Okay. Go ahead and read it for me.
A 5-mile taxi ride is.
Never mind. Lily, you read the next one. Okay. Go ahead, Brooklyn. Good.
A 5-mile taxi ride in one city costs
Anaya.
$25.
Okay. Let's stop for a second. What do we know about that 5 mile taxi ride? How much did it cost her?
$25.
$25. Okay. So let's start with putting this into ratio form. Okay. 5 miles. How much? $25. Okay. Is this an example of a rate?
Yes.
Yeah. Why? Because these are different units, aren't they? This is distance. What is this? It's dollars. Okay, or money, right? Okay. So this is an example of a rate. Okay. Continue, Brooklyn.
A 4-mile taxi ride in a different city costs $18.
Okay. Continue.
Assume the cost in each city is the same amount per mile.
Is the relationship between these number of miles and cost between cities proportional? Let's see. The other city is how many? 4 miles
And
for how much? 18. Okay, so what can we do with these numbers? Cross products. Okay, what's 4 times 25? 100. What's 5 times 18? Can I show you a real quick way to do this in your head? 18 times 5? Can I show you that? Okay, you guys know how to do 10 times 5?
Yes.
What's 10 times 5? What's 8 times 5? 40. What's 50 plus 40? 90. You just did it in your head. Okay, what did I do with 18? I turned it into a 10 and an 8, and I multiplied those times 5. Okay, does 100 equal 90?
No.
No. So is that a proportional relationship? No, it's not. How easy was that? Good. Try this one on your own. Let's see if you get it right. Do this one in your notes. Let's try this. Can you set it up? Okay, somebody help me set it up. What do I know about this proportional relationship? That what? Or how do I know to see if it's a proportional relationship? 6 gallons cost how much?
$13.50.
$13.50, and 8 gallons cost how much?
$18.50.
All right. Well, what can I do here? Find my cross products. Okay. What's 6 times 1880? Let's do that. 0 times 6?
0.
8 times 6? Carry my 4. 8 times 6 again?
48.
Plus 4? 2. Carry my 5. 6 times 1? Plus 5? Okay. How many decimal places? Okay. Now let's do this one. 8 times 1350. 1350 times 8. 0 times 8? 5 times 8. 8 times 3? Plus 4? 8 times 1? Plus 2? Okay. Are those the same? They're not the same, are they? So did those form a proportion? No, they did not. How many of you guys understood how we figured that out? Pretty easy, right? Okay. Abby, are you good? Yeah? Question, Jacob.
So if you had those same numbers
Mm-hmm.
and you wanted to find out which one cost less, would you divide?
Yes, you could divide the top by the bottom to turn each one into divide the money by the amount of gallons to find your, what is that called? Anybody remember? On the schmunit rate. Unit rate, good. Good question. Okay. All right. So let's look at this example. All right. Okay. Lily, you read this one for us.
Christine is building a deck in her backyard. In order to place the post, she'll make concrete using mixture. The mix requires 1 part water to 2 parts cement and 3 parts sand.
Okay, let's stop for a second. What's different about this?
Ratio.
Three things, right? You think that changes anything?
No.
No. Okay, what do we know? One part water to what? 2 parts cement to what? 3 parts sand. Okay, all right, continue.
The relationship between the water, cement, and sand is proportional. If she has 25 pounds of cement and will use it all, how many pounds of sand will she need? 1 gallon of water weighs about 8.334 pounds. How many gallons of water will she need round to the nearest 10?
Okay, so what do we know? This says, from that last sentence, she has 25 pounds of what? Cement, okay? And she's gonna use it all. How many pounds of sand will she need? Well, let's just take these two. Okay, we're gonna worry about water in a second, okay? This is 2 cement over 3 sand. Now, what do we want this, how many pounds of cement did she say?
2.
She wants to use all of it, which is how many? 25. So where's that 25 gonna go? It's gonna go up here, because this stands for cement, right? Right? And what is, this is gonna be X, because we're trying to find how many parts of sand. Okay, what does this look like? Did this look like something we did yesterday?
Yes.
We use products, cross products to solve for a missing portion, right? So let's do this. What's 25 times 3? 75. What's 2 times X? 2X. How do I solve this? Divide each side by what?
2.
By 2. 75 divided by 2. How many 2's going to 7?
3.
3. Bring down my 5. How many 2's going to 15?
7.
What's left? 1. Can I put 2 into 1? So how do I make it bigger? Decimal and how many 2's going to 10? 5. Okay, so if she uses 25 pounds of cement,
I'm lost.
huh?
Sorry, it
That's
went a
okay.
bit fast for me. Why did you put down a 2? You put down water, cement, and sand, and then you put cement and sand
Okay,
again.
because it says that these are a proportional relationship, right? That means if this 2 represents the cement pounds, right? And this represents sand. For every 2 cements, there's 3 sand. Okay, so if there's 25 cement, we're gonna figure out how much sand.
Oh,
Okay, so this is a proportion that we set up, and we're finding this missing part, okay? This, by the way, equals the 2x, okay? Okay, so I have 25 pounds of cement, which means how many pounds of sand? 37.5 pounds of sand, okay? Now, this says, on the next part, it says 1 gallon of water weighs 8.345 pounds. How many gallons of water is she gonna need? Round to the nearest 10. Well, what do you think we're gonna do here? How are we gonna figure out how much water she needs? Somebody give me an idea. Chase?
Well, you could divide the cement, or you could multiply.
Can I do a proportion again? Can I say 1 water to 2 cement equals, how many is this gonna be down here? 25 cement and X water. Can we use proportions for this? We can, right? Let's find our cross product. What's 1 times 25?
25.
What's 2 times X?
2x.
Divide each side by 2. Does anybody know what 25 divided by 2 is? 12.5. We'll save some time. 12.5. Now, how much does 1 pound of water weigh? 1.5. What does it say up there? 1 gallon of water weighs 8.34 pounds. Okay. Yeah. But do you see how we were able to use proportions to solve that? Okay, good. All right. Here's what I want you to do. Open your books